Forces acting on 1 meter length of a dam are shown in figure. Neglecting the weight of the dam, determine the resultant force acting on the dam. Find the point of intersection of the resultant with the base of the dam. First, let us find out this angle made by this 30 kN force. This force is perpendicular to this line and it is 1.25, and this angle is 60 degrees. Also, this angle will be also 60 degrees and this angle will be also 60 degrees. So, this remaining angle will be 30 degrees. So, resolving this force horizontally and vertically. Now, resolving forces horizontally and vertically, summation Fx and summation Fy. First, 50 kN force. This is directed towards positive x-axis, so 50 positive, and this force 30 cos 30 degrees. It is directed towards negative x-axis, so 30 cos 30 degrees directed towards negative x-axis, so minus. Now, calculating all this, we get summation Fx value. Now, summation Fy value 60 kN, it is acting downwards, so minus 60. Now another force 30 sin 30 degrees, it is acting downwards, so 30 sin 30 degrees acting downwards, so minus. So calculating all this, we get summation Fy value, and resultant is given by substituting summation Fx and summation Fy value. We get some resultant, and resultant direction is given by tan inverse of summation Fy by summation Fx. Theta we get as 72.242 degrees. Based on summation Fx value and summation Fy, summation Fx value and summation Fy value, we see that summation Fx is positive, so summation Fx is positive and summation Fy is negative. So summation Fx is positive and summation Fy is negative. So the resultant is in the fourth quadrant, having making angle of 72.242 degrees and magnitude of 78.75 kilonewtons. Now, to locate exact position of resultant, taking moment of the forces about point O. So for this force, line of action of force is like this, and it will have a perpendicular distance of 2 meters from point O, and it will pass along point line of action of force like this, and having a perpendicular distance of 2 meters from point O. So its moment will be 50 into 2, and it will rotate like this clockwise. So 50 into 2 clockwise plus. Now for this force, it will have line of action of force like this. It will pass through point line of action of force like this, and it will have a perpendicular distance of 2 meters from point O, and it will rotate about point O like this, and having a moment of 60 into 2 perpendicular 60 into 2 and clockwise moment, so plus. Now for this force, we need perpendicular distance. This perpendicular distance will be not equal to 2. It is got by this 1.25 meter. So we have this angle as 60. So say it is y by 1.25 equal to sin 60. So it will be y by 1.25 equal to sin 60. So this distance will be equal to 1.25 sin 60. So for this force, this is line of action of force, and it will pass through point line of action of force like this, and it will have a perpendicular distance of 1.25 sin 60 about point O, not 2. This 2 is for this 50 kilonewton force. For this 30 cos 30 degree force, we will get perpendicular distance from this distance and this angle and sin theta. So this force will have a perpendicular distance of 1.25 sin 60 about point O, and it will rotate like this anti-clockwise. So 30 cos 30 degrees into 1.25 sin 60 degrees anti-clockwise, so minus. Now for this force component, it will be line of action of force will be like this, and we need this perpendicular distance about point O, and we want this distance, say it is x by this 1.25 will be equal to cos 60, so this x will be equal to 1.25 into cos 60, so it will be coming to 0.625, and this remaining distance will be we will be getting by 6 minus 0.625, so this will be 5.375 meters, and this force component will pass through line of action of force like this, and it will have perpendicular distance of 5.375 meters from point O, and it will rotate about point O like this. So 30 cos 30 sin 30 into 5.375 meters rotation about point O, and it will be clockwise, so positive. So summation MO equal to this value you will be getting D, that is perpendicular distance of resultant about point O will be got by summation MO by R, substituting summation MO by resultant value we get D value, and x-intercept we will be getting by summation MO by summation Fy, and y-intercept we will be getting by summation MO by summation Fx. Substituting values we get x-intercept and y-intercept. Now what we have calculated is summation Fx value we have, summation Fy value we have, some R value we have, and theta value we have, x-intercept value we have, y-intercept value we have, D value we have. So from point O, x-intercept is 3.634 meters and y-intercept is 11.34 meters, and resultant value is 78.75 kilonewtons, making angle of 72.24 degrees to the horizontal, and a perpendicular distance of 3.46 meters. So the resultant is in the fourth quadrant, having angle of 72.242 degrees and magnitude of 78.75 kilonewtons. So it is having x-intercept, y-intercept, and perpendicular distance. So the resultant is located like this with respect to point